Hello, we will be doing chapter number 2, and now focusing on the periodic table to some extent, and also some of the molecular compounds that we can write and form. So I'm going to share the periodic table. One of the most important things in chemistry is the periodic table, or we can consider it as a Bible for chemistry, because every information that we need is available on the periodic table. The location of the elements gives us a lot of information that are very, very useful when writing formula, when identifying materials, etc. So it is important that we know the terminology of the periodic table, which is basically periods and groups, and know how to use the information given in the periodic table. We recognize the similarities and differences in properties of some of the common elements of the group, and followed by molecules, wherein we are going to do molecular compounds, and we will write the formulas, names, and models. We have to recognize and interpret molecular formula, differentiate between the various types of formula, molecular formula, condensed formula, and structural formula. Recognize and interpret different types of molecular models, remember formulas and names of common molecular compounds, name and write formula for binary compounds. Because the periodic properties, elements were first arranged by increasing atomic number. At first, they were written as not increasing atomic number, but by an increasing atomic weights. That was the property that was used in order to show the periodicity of the elements by Dmitri Mendeleev and Lothar Meyer. However, today, the atomic law of assigning period elements is based on increasing atomic number. Because in 1871 or so, when the periodic table was first put out, there was no information available about the electronic configurations of elements. And so now we see that elements, the periodic table law says that elements are arranged by increasing atomic number, and previously it was by atomic weight. When atomic weights are considered, there are some discrepancies on the periodic table. However, when atomic numbers are given, and even though at the time of Mendeleev, it was electronic configurations were not known, was still able to predict very, very accurately unknown elements, such as he gave the name below silicon as eka-silicon. Later on found to be named as germanium, and as per Mendeleev, the properties that he studied were atomic weight, which he predicted in 1871 as 72. The density of this particular element would be 5.5, specific heat would be 0.305, melting point was high, the color was dark gray, the formula of the oxide would be XO2, density of the oxide was 4.7, the formula of the chloride was XCl4, and the density of the chloride would be 1.9, and the boiling point of the chloride would be under 100. In 1886, eka-silicon was discovered and named as germanium, and at that time, the atomic weight was found to be 72.59, density 5.35, specific heat 0.309, melting point was found to be 947. The color of the element was grayish-white. The oxide formula was GeO2. The density of the oxide was 4.70. The formula of the chloride was GeCl4. Density of the chloride was 1.84, and its boiling point of the chloride was 84. So you can see how much accurately he could predict an unknown element at that time. Now, when we look at the periodic table, we have to know certain terminology, and they are periods, groups, metals, non-metals, metalloids, halogens, noble gases, alkali metals, SPD and F, and lanthanide and actinide series. Now, all these metals, non-metals, metalloids, halogens, noble gases, and alkali metals generally are related to the position of the elements on the periodic table. When we consider metalloids, we assume that they can behave either as a non-metal or a metal, depending upon the circumstances. Halogens are those compounds which are salt producers. Noble gases are which are inert gases. And the alkali metals are highly reactive. So if you look at the periodic table over here, and just look at the vertical columns. The vertical columns are called as groups or families, and we generally represent them as A and B groups. The A groups, elements group number 1, 2, 3, 4, 5, 6, 7, and 8 are called as representative elements. Whereas the middle block in between 3, 4, 5, 6, 7, 8, and 1, 2, they're called as the B block elements that are present. Furthermore, the classification can be further divided by going across the horizontal rows, and the horizontal rows are called as periods. And we see the coloring. The main group elements are in blue. The transition metals are a shader dark in blue. The metalloids are seen as a green color. And then, of course, you see the metalloids are also called as the bridge elements. And beyond that, you see in yellow or ochre color, the non-metals. Hydrogen has the unique position whereby we can place it either in group 7 or in group 1. And it is a non-metal, because of its difference in reactivity with different elements that are there. Next, molecules and compounds. Molecules are the smallest unit of a compound that retains the characteristic of the compound. And it can be a result of non-metal combined with a non-metal that is present. Compounds are a combination of 2 or more elements in definite proportion or ratios. By mass, the character of each element is lost when we form a compound. The formula of a compound can be shown or indicated in different ways. One is, for example, if we give the name of the compound, like ethanol, which is an molecular formula of the molecular compound, or dimethyl ether, another organic compound, you will find that the molecular formula for both the compounds are the same, because they have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen. But it is the arrangement of these atoms that differentiate the properties and the name and the structure. Therefore, when we look at the molecular formula, it is not possible for us to tell how the atoms are arranged. But under the condensed formula, we can get a clear depiction of how the groupings are assigned. So for ethanol, we write it as CH3, CH2OH. And for dimethyl ether, we write it as CH3OCH3. And then even this, to some extent, does not tell very explicitly how the atoms are arranged with respect to each individual atom in the molecule of the compound. And therefore, we get the structural formula. And you can see how the structural formula looks. They are just shown by joining by single lines, which are actually chemical bonds that are available for the atom. So each of the atoms are connected to the center atom, and so you get the formula. And the last is called as the molecular model, where we generally call the molecular model as the space-filled model because it shows the entire space occupied by the various electrons of the various atoms and then derive the structure from it. Now, when we do the space modeling or a molecular modeling, then it is very important that we are able to differentiate between the different atoms that are present. And this is done by giving a color coding. Carbon is given a gray color, oxygen is red, hydrogen is white, nitrogen is blue, and chlorine is green. Generally, these are the main colors that are given for molecular model. And another way of representing the various molecules of methane gas, CH4, is shown. The first one to the left is what we call as the simple perspective drawing, where it shows coming towards you and going away from you. Another one is the plastic model. Next is the ball and stick model, and then space-filled model. And when we put all of them together, we get the visualizing technique representing the same model that is there, because now it is superimposed with the actual structure of the perspective drawing of the methane on top of the structure model, space-filled model. Now, whenever we name molecular compounds, when non-metals combine, they form molecules. They may do so in multiple forms. For example, carbon monoxide, CO, and carbon dioxide, CO2. Because of this, we have to specify the number of each atom by way of a prefix. And the prefix used is mono, di, tri, tetra, and so on and so forth till you reach 10, which is deca. Many times we can, the first element generally is not given a prefix, but sometimes it may be required to give the prefix for both the nonmetals. Or in this case, for example, boron trichloride. The element that is placed to the right drops a few letters in his last name, and then we call it, change it to IDE, so that chlorine, INE, is dropped and replaced by IDE, so you get boron trichloride. The left element, the name is fully stated very clearly. Sulfur trioxide. In the same way, S stands for sulfur, so you get sulfur. And then tri means 3, oxide means 3 oxygen. Now, NO, we write it as nitrogen monoxide. See the spelling, monoxide, that is there. And we don't write mono nitrogen. So check the spelling. And then for N2O4, because now we know that nitrogen is a nonmetal, oxygen is a nonmetal, and therefore we have to write the number of atoms of both the nonmetals that are there. So we say dinitrogen tetroxide. So here are some other examples that you can practice on in order to make sure that you understand how to name molecular compounds. And with this, I'm going to stop the presentation, because the remaining slides all deal with concepts, applications, and position of elements on the periodic table. So I would say you look at it, check out on the periodic table and name which group, which period, so that you don't make a mistake.